All right. Thank you, everyone. Hello, everyone. Thank you for joining today. Welcome to the webinar. Today's webinar is on integrating Sonar clean code practices in the AWS CI/CD workflows. Today, you will learn how to leverage SonarQube, AWS cloud services, and DevOps solutions to build modern CI/CD workflows with clean code. I am Manish Kapoor, and this webinar will be co-presented by AWS and Sonar. Thank you to AWS for collaborating with Sonar on creating and delivering this content. Please allow me to quickly go over some essential housekeeping points before we start. This session will last about 60 minutes and include a Q&A at the end of the webinar. You are invited to submit your questions via the Q&A box in Zoom. Please note it's the Q&A box and not the chat box. We have two panelists joining us today. Thanks Kevin Nash from AWS and Emmanuel Colosi from Sonar. They will be here to help answer as many questions as they can live during the webinar. This session will be recorded and we will share a link via email in the upcoming days. Finally, at the end of this webinar, a short survey will pop up on your screen. We consider your feedback as a gift. Thank you in advance for participating in the survey. So without further ado, let me introduce you to today's speakers, Sylvain Com and Ramon Lopez. Sylvain is a former Java developer who has held several architect positions in the last 15 years. He joined Sonar sales engineering team as a senior consultant in 2020, and he has been providing technical support, guidance, and best practices advocacy to hundreds of customers using Sonar solutions around the world. Ramon is a senior solutions architect at AWS, where he guides, educates, and empowers customers of all sizes and industries to build successful businesses in AWS cloud. He also has built web services for over millions of Amazon Prime customers and led a team of software engineers in a fast-paced global environment. Thank you, Sylvain and Ramon, for delivering this webinar today. Over to you.
Thank you, Manish. Let's start with the webinar. Let's start with the content. Let me first say thanks for the invitation and thanks for having the chance to collaborate with all of you and having the chance today to talk about all of the things that we've built and share them with the audience. So the scenario of this use case, so to say, this scenario of today is that we want to talk about, in general, the integration between Sonar and AWS. And the scenario is that as a development team, you have, for example, a Java application, but it could be, a lot of other programming languages as well. It could be a C# application just as well. In this case, we took the example of a Java Spring application that we want to deploy on EKS. So it's a Kubernetes-based application using Amazon EKS as the deployment target. And we want to guide you through this whole approach, how to achieve a clean code state with automation, so with the CI/CD pipeline and all of the DevOps tooling that AWS and Sonar offer. And of course, we're also going to cover what is essentially clean code. We'll talk about what are those different options you have in terms of CI/CD tooling. We'll talk about SonarQube, Sonar Cloud, and SonarLint. And in the end, we'll have questions as well. I will have time for questions. So the scenario as an architectural diagram is what I just described. We have this application that is in this EKS cluster, as you see it on the right-hand side. And it's essentially a Docker image. you have your developer on the left-hand side. The developer works on a repository, a source repository, a Git-based source repository, and uses AWS CodeCommit for that purpose. So we'll go into more detail of how this looks like, but I'll just quickly walk you through it. As a developer, you commit using a feature branch model, using pull requests into this CodeCommit repository. And you have a AWS CodePipeline that listens on the main branch of this repository and deploys, builds, deploys, tests all of your changes. And then at the same time, you have Sonar analysis happening within this pipeline. Additionally, what we will see in the webinar today is how to also use Sonar pull request analysis. And for that, we built a few things. And the supporting services that we will see are Amazon Event Bridge and Secrets Manager. Yeah. And so before we'll talk about the poll, we'll quickly talk about two self-learning resources. We will send out those links in a follow-up email as well. But all of the content that we discussed today, so exactly this architecture, you will find it in AWS Workshop Studio. So these are the instructions for the workshop. And you can see a step-by-step guide there. And then the other resource that we will send out is a GitHub repository, as you can see it on the screen right now, which is, so to say, the markdown version of this workshop with a lot of automation. So you can set up your environment, using CDK, so the AWS Cloud Development Kit, and you can recreate what we have built, and you can see how everything works and how everything is so to say, connecting. Okay. So when you signed up for the webinar today, you filled out a poll, and we have asked you, for example, how many of you are using Sonar and AWS DevOps solutions? And we've got a few really interesting results from that poll. So first of all, we saw that we have people joining from all over the world. So really from all continents, we have people joining in the webinar. We have about 1/4 of you who are using both Sonar and AWS solutions currently. This is great to hear, of course. We have quite a few people who have not used AWS DevOps solutions but are interested in knowing more, and we're hoping that we can shed some light on that today. And the vast majority of the registered audience is using either Sonar Cloud or SonarQube. So many of you are already Sonar users. And so we'll go to the next poll, a quick live poll here. And the question is, are you looking at implementing Sonar analysis for the first time, or do you have it in your workflows already? So, and the poll window should appear on your screen. And I would ask you to answer that question right now. Cool. So what are the results? So the results that I'm seeing here, 70% were saying yes, they are looking to implement Sonar analysis for the first time. So it's a good split. So we have quite a few people who are first timers and quite a few people who have already done that. And just as a reminder, you can close the poll window with the close button as well. Yeah, over to Sylvain.
Thank you, Ramon. Hello, everyone. Just a few slides before we go into the technicalities, let's say. So bad code is a problem that is common to every organization. Software is everywhere. and the cost of the bugs, the vulnerability is enormous. Some studies have weighted this cost at billions, not millions, but billions, or even trillions. And all of you know that developers, they spend a great amount of their time just maintaining the existing code. So the power of clean code is in three areas. So developers, they can achieve more if they don't spend 40% of their time remediating issues in the code. That's all the more time that they can implement, innovate. It will reduce the risks for your organization, of course. The 90% of the security incidents that are caused by poor coding practices can be avoided. And of course, software is an asset, and you want to take care about this asset and increase its value over time. So what is the Sonar clean code? The code that can be statically analyzed as consistent, intentional, adaptable, responsible. Those are qualities that can be measured automatically in your pipeline, as we will see. And this will result in applications that are maintainable, reliable, and also secure. And this applies to everything, not only your source code, but also scripts that may be around this code, and the test code, and of course, infrastructure as code. You have Docker files, you have Kubernetes configuration files, you have code to deploy the application. This code must be secured and safe, and also reliable. Clean as you code is the methodology that we promote here at Sonar. This is the one way to implement Sonar analysis automatically in your workflows, hopefully, so that developers, they can smoothly increase the quality and the security of the code base. No new vulnerability, no new bug is introduced in the new code, in any new commit. The quality gate, which is measured by SonarQube or SonarCloud, is abided to. Don't promote some code that is failing the quality gate. And this methodology will progressively address issues everywhere in your code base. And any new increment in the code will be completely clean. And that will systematically improve the code quality and security of your entire code base. And that fits with your DevOps workflows. Of course, there are plenty of tools around, but there are main ones. And they are well supported by SonarQube. We will see that with SonarLint a bit later. So SonarLint is the linter that we propose to every developer. It's free open source. But when you connect it to SonarQube, you have additional functionalities. And already with SonarLint, you can make sure that your new commits are clean or almost clean, even before you commit. And also there are some issues that you don't want to even push to a repository, like secrets. You don't want to expose secrets even in a repository you have. It's very difficult to get rid of them once the commits are pushed. And then you iterate within DevOps, of course, with SonarQube or also SonarCloud, and that integrates with your DevOps tooling, AWS, CodeCommit, CodeBuild, CodePipeline, or others. Quality gate will be systematically computed on every analysis, and this is what validates the code and allows the developers to go to the next iteration, the next ticket, the next addition in the code. Okay, so now is not the time for the next question. Let me just illustrate a SonarQube instance here that is running on AWS, on EKS. It has been deployed thanks to the instructions that were provided in the two resources that were mentioned by Ramon. So this CI/CD tutorial on GitHub and this AWS Workshop Studio resources. So deploying SonarQube to AWS EKS is not difficult. It's not the only way to do it. Here we are on a SonarQube 10.3, the last official release, developer edition, a commercial edition that will provide the necessary functionalities for today's demonstration. Two of them are very important. The first one would be branch and pull request analysis, not only one branch analysis per project. And the second one is taint analysis. If you want to detect advanced vulnerabilities related to tainted data propagation within the code, you need a SonarQube Commercial Edition or Sonar Cloud. This is running in EKS in the EU West 3 region because I'm French, so I deployed it to Paris, but of course you can deploy anywhere you want. There are so many regions available for you on AWS. What is important is that most parts are running in the same region, of course, so that the performances and the network performances are very good. In this cluster, we have very simple and small nodes running, C5 large, 2 vCPU, 4 gigabytes of memory. You can start small on SonarQube and you can scale when you need it. Here we had only a simple application to run and a rather small SonarQube instance, so no need for much hardware to do that. That's what we did here. How is it deployed? It's deployed through an Helm chart. So Helm is the official way to deploy to Kubernetes for SonarQube. And we provide an Helm chart, and you, of course, on top of the values that we provide, you provide your own. Typically here, we have set the developer edition, the repository SonarQube, 10.3 developer, the tag. That's for the version. We disabled a few things. As I mentioned, the footprint, the hardware footprint from this instance is very low. Here we attach to the VPC the network on EKS. So for this particular demonstration, there is no complex network setup, a VPC, no HTTPS, but that is fine for a demo with non-private code. Also, we use the default Bitnami PostgreSQL chart, a PostgreSQL database, which is not really typical. It's convenient. You can run some tests, but it's not typical for production setups. Most of our customers, they would use RDS, some of them also Aurora, or they will host their SonarQube instance in a pool of database on some other cluster, typically, and you would not see user or passwords in clear text in any Helm chart. Of course, you would obfuscate that as a secret. We will show you a bit later how secrets are used. AWS secrets can be leveraged in workflows. That should be the same for Helm charts. Okay, so on this SonarQube instance, I already had a first analysis of the project. Many of you are already a bit familiar with SonarQube. So this is gathering the main indicators about the cleanliness of this code, the number of bugs with a reliability rating, the number of vulnerabilities with a security rating, the number of hotspots that were reviewed or not, the code smells, the test coverage, and the duplication, which are the most important metrics measured by Sonar analysis. Okay, so that is for the SonarQube part. For the SonarLint part, SonarLint is running within your IDE, can be any JetBrains editor. So here IntelliJ for Java development, very popular, but it could be VS Code as well for Java. It could be Eclipse, of course, still used by many developers. And we also support Visual Studio. So depending on the language you are using, you should find support with SonarLint for free. It's open source for your developments. And already we can see that SonarLint is raising some issues on this code. And that is nice. I can see the documentation. I can apply some change and get real-time analysis of my own code. Okay, I mentioned that it gets additional functionalities when you connect it to SonarQube. So here it is connected to SonarQube. So of course I have access to multiple instances, but here I connected it to my AWS instance with the project key. it was done very smoothly. You generate a token, you can initiate that directly from your editor, and it will align the rules that run both sides. So what is measured on your DevOps automation workflows is also measured within your editor. So you align with what is said for your team. And every issue status is also aligned. So if you mark something as not needed any fix from SonarQube, it will not be raised to your attention again and again in your editor. And there are many other functionalities that were added recently, like the possibility to mark issue as won't fix, even before you can commit the code. You can also review hotspot, you find links, both sides. So really, they are working closely hand in hand. Okay, Ramon, I believe you should take the lead back to speak about the rest of the pipeline.
Maybe you can switch to the original diagram we had in the slides, and we can position ourselves back on the diagram to understand where we are, what we're talking.
Of course.
So
this one.
Exactly this one. So what you just saw is SonarQube running within this EKS cluster, and this is just, let's say, part of your CI/CD, part of your development environment. You have an instance of Sonar that is running and ready to analyze your code at all times. And what we will now zoom into is this pipeline. So this AWS CodePipeline and all of the components that belong to the pipeline. And essentially, we want to understand how we can use the Sonar analysis within the main branch and all of your feature branches. So this is AWS CodePipeline. So you have a top to bottom pipeline, so to say. At the top is usually a source stage, meaning this is a repository. It could be, in this case, CodeCommit, or could be a Bitbucket or GitHub repository as well. And the pipeline is connected to one specific branch. So in this case, it's the main branch. Then just scrolling down, we would have other stages. In this case, we just have one build stage. And that build stage is not only building or compiling code, but it is also, as long as the Sonar analysis was successful, the quality gate was green, it is also building a container image, and it is pushing to that Kubernetes cluster. So yeah, if we switch to the CodeBuild project, which plays a really crucial role. So this is the CodeBuild project that is referenced in the pipeline. And you can see, for example, that it has a source provider. You can look into every build that recently ran. You can see the build logs for every build. And it's a fully managed environment, right? So there is no build server for you to maintain. There is no operating systems to update. You essentially choose the image that you want to use for this build, which are provided by AWS. And you provide a so-called build spec, which are all of the instructions for this build. If we stay on this page here, 1 second, can you click on environment variables in the middle? Here, I'm just showing you this because this is something that we will encounter a few times in this workshop, in this scenario. We leverage environment variables, and we leverage this same CodeBuild project for both the builds in the pipeline, so the builds on main, and also the builds that are triggered by pull requests. And the way we differentiate between those two types of builds is by using environment variables, which are being passed in from the outside, so to say. So you see the source branch, for example, being passed in. So maybe we can actually look at this build spec, this instruction, and how the build job should look like. Yeah, you should see it in the repository. So this is the CodeCommit repository where you have your Java application. And then one file is typically called buildspec.yaml. And this is the file that CodeBuild is looking for. So typically, it's a YAML script. At the top, you define things like your environment variables. Here, we also see two important lines, line 4 and 5, which are references to Secrets Manager. So AWS Secrets Manager is a service that helps us to manage all kinds of secrets. In this case, it's the Sonar global analysis token, and also the host URL of your Sonar installation. So this is the URL that points to Sonar that is running in the EKS cluster. And the reason this is nice is because you don't have to have any credentials or passwords in YAML configuration or in source code. You just have this reference to Secrets Manager. And then CodeBuild, so your CodeBuild project, is authenticated through IAM roles to access those secrets. So if we quickly jump to Secrets Manager, you'll see how this works. This is Secrets Manager. This is the secret we're using and referencing in the CodeBuild build spec. And essentially, this is where you would define who or what can access the secrets. And CodeBuild is nicely integrated with Secrets Manager. It has an IAM role, and that role is allowed to access the secret. And this happens at runtime, so to say. So then going back into the build spec, we see a few environment variables that are defined. And then starting on line 19, we have different phases. And so those phases correspond to for example, an installation phase where we would install the tools that are needed to compile and build and test your application. And then you have a phase to actually build. In our case, we're building so the most important line was probably line 61, where we have this Maven command that installs, but it's also where we trigger the Sonar analysis. So this is where we leverage all of those environment variables, saying that, this is our source branch, this is our destination branch, if it's a pull request, and this is our Sonar token and the Sonar host URL, and we trigger the analysis. And only if that stage, that the code build stage is successful, meaning the compilation was successful, the tests were successful, and also Sonar reported a successful analysis, then this post build would start and we would actually deploy to the Kubernetes cluster. And I think it's clear how this works in CodePipeline. CodePipeline triggers this code build job. But now the question is, how do we make this work for pull requests? And maybe we should even take one more step back and ask, why is this interesting? Why is Sonar analysis, static code analysis important in a pull request? As you've seen, we have information, or we want information about our code quality as early as possible in the development cycle. So we don't want code analysis only once we have merged things into our mainline branch. We want this to be available at the stage of the pull request. So for example, for the reviewer of the code to also have a look. And this is where the pull request analysis becomes really interesting. And then also we want, even earlier in the cycle, this information for the developer in their IDE. So at every stage in this process, you have up-to-date results from Sonar analysis, and you can make adjustments. And this helps you in the long term because you can fix code smells and coverage issues much, much earlier. And the way we make this pull request analysis work is by using an event bridge plugin, we call it. And this is something that we provide to you it's also linked in the workshop. It's a CloudFormation template you can simply deploy, and you just provide the name of your repository and the name of your code build project. And this CloudFormation template will set up this rule here. So we don't have to dive into a lot of detail into how the rule actually looks like and how it works. But essentially, you need to know that you can deploy this. The event bridge rule will listen to pull requests on that CodeCommit repository. And every time a pull request is opened or updated, it will trigger the same CodeBuild project, and it will trigger Sonar analysis. And later on, you will see how the Sonar analysis, the pull request analysis looks like in the Sonar UI. And you can compare, let's say, the code quality on that feature branch with the main branch. Did I forget anything to mention, Silva? What else do you want to say here?
Maybe you wanted to mention that you have this project on GitHub available.
Yes, exactly. So this is the plugin. So this is really just a CloudFormation template you can use in your own environment. So if you use CodeCommit as a repository, and if you use CodePipelines and CodeBuild, and you want to leverage not only the analysis on the main branch, but also on pull requests, you can simply deploy this little CloudFormation plugin and use it.
Great. So maybe we should just create a pull request and see what happens.
Yeah, let's see how it works.
Okay, so of course we don't want to create some code live with you. So there is a branch that already exists on this repository where we typically add some service. So the service is running. It's running in the cluster. It's serving only one URL for hello world. It's a Spring Java application. And the idea would be to add another web service on top of that. And we have a branch ready for this here. So I will just try to promote my changes through a pull request, very simple. In CodeCommit, I select the main branch as the delivery branch. I select the new service branch as the source branch. And this is where I will collect the review from my peers, but also the results of tests and static analysis, of course. Okay, so I can go ahead and add the new service, create pull request, and automatically I expect that this pull request creation triggers some CodeBuild project run. So if I go to CodeBuild, okay, it's already running. And it will take a minute or so. I can highlight the logs and maybe comment on them while this is running, waiting for the results to be available and the quality gate to be computed.
And maybe just to explain what happened in the background, whenever you created that pull request, it's essentially an API call that EventBridge would listen to. And we listen to this exact pattern. So new pull requests or modifications of pull requests. And then it essentially goes and triggers the CodeBuild job that you have defined when setting up the CloudFormation template.
So then we are in the pre-build step. The build agent is installing everything. Okay, downloading the source as well. Of course, that is common to any CI/CD solution. So this pipeline is not completely optimized. There are a few things that we could remove in the case of a pull request. So we trigger a build with different parameters so that SonarQube understands whether it's a main branch or a pull request that is analyzed. But we could as well remove some of those pre-built preparation of the build agent, this is a Docker image, in fact. Okay, so here we are running the Maven build and analysis. Depending on the language of your project, you would have a different scanner, but the idea is exactly the same. The project key is run, and now we can see the sensors are running. So the analysis proper is being done. We can see that the Docker sensor is running as well. Here CPD code duplication is being computed. And we also add some traces about taint analysis. Okay, so here, if you see UCFG in the logs of your Sonar analysis, it's for a universal control flow graph. That's how Sonar analysis will check all the data propagates within your code and typically secure some critical endpoints in your message, in your workflows, in your code. Okay, so this has failed. And this has failed for a good reason, I would say. We have this parameter here that will allow you to enforce the quality gates. So Sonar scanner is waiting for the quality gate status from SonarQube, and the command will just fail in case the quality gate is failed. And we should be able to see this result here. So I go to the web service, the main branch is okay, and I have a pull request that was analyzed. There is one condition for every issue, and this condition is mandating that no problem should enter the code base, no new problem should enter the code base. So 5 issues require fix, 2 security hotspots require some review or maybe some change, and everything is actionable, of course. So let's see what's raised here. App controller, remove this field injection and use constructor. So this is a good practice for injection in Java Spring projects. Here we have the same problem for another class. We have a system out logger command that is stuck there, and we maybe have something blocker here. So more important maybe, which is a SQL injection vulnerability. So we have one injection flow. I can see that, okay, the request mapped to person/address URL is reaching here a sink, so a JDBC query construction without sanitization. So it should be possible to escape here the boundaries of a single SQL request. So let's maybe check that. So I have Visual Studio open, I am on the right branch, and I am able to maybe build. I will make sure that I am on the right build. Then I can run this. Okay, so it's running locally. As a developer, it's interesting to see what's happening there. And okay, so I should be able to extract the data from all users to insert new data. So let me just copy this. So here, special syntax, thanks to the security researchers here at Sonar, it's not that difficult, but if you are not familiar with this syntax, you don't know, it can be done. So this results in an error, but now I can also extract all data from the table where I would expect. So this was injected into the database while I was originally only having this. And I can also truncate the entire database. So this is the entire table. So no worry. Now I can go back to. So the service is still running. And okay, now I want to see everyone. But of course, there is no one left because someone controlled the database and removed all of the data from the people table. Okay, so let's see how I should address the report from Sonar analysis. Okay, I can stop this and go to SonarLint. So this is one of the issues that was raised. So here I need to declare this as private final, and then I will make a constructor. So this should be highlighted in the documentation. So it's not only clean as you code, but also learn as you code. So here I make a new constructor with data utils this dot tu, and obviously I want to auto wire the constructor and not okay. So that one is solved. I have the same problem with data utils. Here I can also remove this leftover from the development phase, and same issue here. So I will create a constructor, make this private final. Okay, and this dot jdbc template. So very easy. The documentation helps, of course, for me with former Java developer. I'm a bit rusty, so always I need the examples that are provided by Sonar analysis. Let's get back to SonarQube and see the result here. So why is this an issue? If I want to read about it, plenty of documentation about why this is a problem. Of course, we have proven that this was a problem. How can I fix? Spring was detected on my project, so I get examples that are really focused on Spring example. It's nice. I can see here, okay, the query is assembled. Okay, so I need to put some placeholders in a string and make sure that the request cannot be escaped. So that would be in the file. Okay, app controller, of course. It's here. So thanks to Kevin, panelist today, for this nice vulnerability. So it's no data utils. Okay, data utils. Hello. I will declare a query. Just taking the query from here. Okay, just need a placeholder for the parameter, of course. So query is called for string.class, and then name, which is the parameter that we acquire from the web service. Okay, we should be good to go. Here, there are probably a few things that I need to address again. So let's get back to the overview. There was 5 issues. I probably removed 2 of them. 3, 4, and this public modifier. Oh yes, I can learn also about best practices regarding JUnit. So here in JUnit version 5, I should not make the test methods public. So here in the test code, okay, I can address that globally. No worry. And here. Okay, no more issue. Let's make sure I saved everything. Security hotspot. Okay, the request mapping here on person address is not very good because it allows get, post, every kind of request. And obviously, we should restrict the scope to gets, which are much safer. Okay, as is highlighted in the documentation again. So let's get to it and use a get mapping instead. Okay. Why did I open that? Probably did a wrong document turn. And now I have this import which is not used anymore. Okay. And done. Let's commit. So three file change, apply fixes, commit and push. Okay, I can also find some warnings from IntelliJ, but we should be good here. Okay. Commit and push. Of course, CodeCommit is a regular Git repository, so no worry there. And I should be able to see the projects be the same pull request updated with a new commit, triggering a new pipeline, a new build and analysis. And hopefully this time the quality gate will be successful. And we'll have the opportunity to see these results in a few more minutes, but until then, I guess we should go to the next step. We are almost there.
Should we do the second poll? I mean, let's do it. It won't take much time. Let's do a second poll here, and then we'll do a very quick recap and open it up for questions. Do you want to leverage AWS solutions in your DevOps workflows as well? I'd be interested to know. Also, now that you've seen how things work, really interested to know how people think. And in the meantime, you can also think, if you have already questions in mind about any of the content that you saw today. Good. So we look at the poll results. Okay, so we have about a 50-50 split, pretty much. Nice. Cool. So I'll do a quick recap of everything that we saw. Essentially, we talked about a complete end-to-end flow of deploying Sonar in Amazon EKS, deploying a pipeline, configuring the pipeline, and using the AWS Sonar Event Bridge plugin to also support pull request analysis. And then we saw how we can use not only Sonar Lint, but also SonarQube within the pipeline and within pull requests to shift left, essentially, in the spirit of shifting left, allowing the developers to have full insights into code quality from a very early stage and throughout the whole development process. And so in the end, you saw actually a real security vulnerability in this Java application that Sonar called out. And Sylvain was able to show you that this is, or this was really susceptible to a SQL injection. Sonar called it out, and Sonar also gave us really good hints on how to fix those issues. And how now, once we trigger this fix and we trigger an update on the pull request, we will then see in Sonar how the analysis changed and how those security vulnerabilities hopefully disappear.
Yes. So, as expected, they were fixed. They disappeared.
Amazing.
Yes. So they will remain. They should remain for a while in the database, but as marked as fixed, attached to the code. So this is very nice. Yes. And now I'm ready to merge this pull request. The CodeBuild pipeline project succeeded.
Perfect. So let's open it up for questions from the audience.
All right. Thanks to both of you, Ramon and Sylvain. That was a great session. It was an end-to-end demo, like you said, Ramon, where a Java developer is using AWS CI/CD pipeline and has integrated SonarQube into the CI pipeline to deploy a bug-free Java application. You found a security bug, and Sylvain was brave enough to try and fix it, and then run the pull request analysis again, and deploy the application into a AWS Kubernetes cluster. As we move into the time of into the Q&A session, I will gather some questions for you. But I briefly wanted to talk, let you know about our upcoming webinar. It's on December 14th. It's on Misra C++ 2023. There should be a link which we'll share in the chat, as well as it's available on our website. I encourage you to attend this webinar. It's again a collaboration between Sonar and a Misra C++ industry expert. We will talk about how C++ code can be made safer, and you can adhere to the Misra C++ guidelines. As a reminder, after the Q&A session, we will have a short survey up here for you. And we would greatly appreciate if you could fill that survey and send us your feedback so that we can improve our future webinars. All right, so let's get into the Q&A session. I do have some questions which are pending. So this one is probably for Ramon. Is CodeCatalyst supported as well as with Sonar analysis?
Yeah, I think we can also look at a resource that the Sonar team has published recently about CodeCatalyst and Sonar. Sylvain, do you have that handy?
I'm not sure I know what it is.
Yeah, I think it's the CodeCatalyst documentation is there in the Sonar Cloud documentation. So if you go to Sonar Cloud documentation and search for CodeCatalyst, you should be able to find how to integrate CodeCatalyst with Sonar Cloud. Can I use Argo CD or some other CI/CD pipelines, to, instead of the ones that you showed, you demonstrated, can I use something else like Argo CD instead of CodePipeline?
Sure. Yeah, absolutely. I think we showed one possibility using CodeBuild as a build tool, but then also as a tool to deploy. We can also point you to the AWS EKS workshop. So it's awseksworkshop.com. And essentially there is a good example of a EKS CI/CD workflow using Argo CD. And essentially, you can combine tools however you see fit. So definitely Argo is a tool that we see a lot of customers using. And you can use it in a combination with Amazon EKS as your Kubernetes platform as well.
Okay, thanks, Ramon. I will pick up some of the questions which came in through the Q&A chat, which I think are probably appealing to most of the attendees. Is it possible to scan only the changes made by a PR to improve the performance of the scan?
Yes, I can answer this one. Yes. I should answer this one. Yes. Pull request analysis is much faster than a full branch analysis, and it also raises any vulnerability that is sourced, that takes its source or is finalized outside of the PR itself. So it's very important to highlight that the pull request analysis is faster and is also very good. In a very small project like we had, we don't see a difference because the analysis time is so small. But usually Java application or any application can be pretty big. And if the analysis time for a branch is 20 minutes, for example, that can happen. If your project is big, pull request can be done in minutes. A couple of minutes.
All right. Yeah. Thanks, Sylvain. I think there was another related question. Is pull request build available in community edition of SonarQube? Pull request, like I answered to that question, is a commercial only feature. So you would have to go to developer edition or higher to get that. You can do the full branch analysis in the community edition. So for this feature, you do need to have a commercial edition. Is it possible to get a similar integration that you all demonstrated today using GitHub Enterprise? Yes, we can integrate with other CI/CD providers as well, like GitHub Enterprise. You can, in particular, you can imagine the whole demo with any other CI/CD provider, such as GitHub Enterprise or Bitbucket or Azure DevOps or AWS services. You can plug in any of the CI/CD services for the demo. So yes, we integrate with almost all the CI/CD services. SonarQube does integrate with all the CI/CD services.
And you can mix and match. There are many GitHub repositories that are built on AWS, and there is a good integration between GitHub and CodeBuild, if I remember correctly.
Yes.
There's one last question before we wrap it up. Can I set this up for bugs and vulnerabilities that will cause a build failure and not and skip the code smells, right? So only enforce the code quality for bugs and vulnerabilities. Yes, you can do that by creating a custom quality gate.
Yes, we recommend not to do it, maybe, because over time, the maintainability problems, the code smells, they will accumulate and make evolution of the code base a bit harder. But it's always up to you what you are applying as condition in the quality gate. So this new code has zero issue is easy to implement and understand for every developer, but you can definitely make that slightly different and target only vulnerabilities and bugs.
All right. We'll wrap it up now. Thanks, Ramon, Sylvain, and everyone else who helped with this webinar. And thanks to all of you who posted questions. I think we got to almost all of the questions, but if we missed any, we will try to answer those and post the recap on our community. Our community is a great place to pose any additional questions that you may have. So please do stay connected with us and visit sonarsource.com for anything that you want to learn about Sonar products, such as SonarQube or our Clean as you code methodology. And also check out the information about our future webinar and events. Thanks again for participating in the survey that will show up. And I look forward to seeing you all in a future webinar. Thank you all.
Thanks, everybody.
Thanks, everybody. Bye.